Hi everyone, I'm Yuki. Today I'll talk about digital signatures. Alice and Bob 0.5 Bitcoin. You see a line like this in every crypto diagram. But on a network with no boss, how do we know this really came from Alice? Send a password and it gets stolen. A handwritten signature can be forged. The answer is to register the digital signature. Then let's just do it. Then type a message like this and hit seal. And now there is our green seal. It's a one-of-a-kind mark made from your secret key plus this exact message. Now change a single character like this. And the seal cracks. A signature is bound to one exact message, so it can't be copied or reused. This page lets you feel the whole thing while learning real cryptography right in your browser. Let's play with all of it. Hit subscribe and let's go! First, why signatures? If everyone shares one secret password, then anyone who can check it can also forge it. Being able to verify means being able to impersonate, like this. So we split the key in two. A secret key for making signatures and a public key for checking them. Now only you can create a signature, yet anyone in the world can verify it. Data symmetry is the foundation of everything here. A signature gives you three things: authenticity, who sent it; integrity, that nothing changed; and non-repudiation, you can't later deny it. Let's make a key pair. The red one is your private key, the blue one is your public key. The private key is just a random number and the public key follows from it instantly. The magic is that you can't go backwards. Picture it on a clock. Forward just means hopping a fixed number of times from start, like this. Easy, you are only counting. Now the reverse. Hit gets the reverse. You only see the landing spot in gold. How many hops was it? You can only try them all. The landing gives you 0 hints. Like this. This toy has just 23 points, so it's instant, but real CESP 256 K1 has about 2 to the 256. For more than the stats in the observer universe, you can never try them all, so it can't be reversed. That's the heart of public key crypto. Let's take a signature apart. Click sign. Like this. First, the message becomes a hash, a short fingerprint. Then we need that fingerprint together with your private key and a one-time random number. And out comes the seal, the signature. And a quick mythbuster. People say a signature is a hash encrypted with your private key. For the schemes Bitcoin and Ethereum use, that's wrong. Signing isn't encryption. It's a dedicated procedure that only ever checks authenticity. Here is the fun part. Sign the same text again, and it's a different seal. Yet both are genuine because each one uses a fresh random number. Hold onto that random number, it becomes critical later. Now verification, and this is the climax. You are the attacker and try to sneak something past the check. Alice sealed pay Bob 0.5 BTC. Let's rewrite it. Change the pay to us and bump the amount. and instantly rejected. The message changed. That's integrity. And what if we use a different key to pose as Alice? Then, also rejected. The key doesn't match. That's authenticity. Then, tamper with the seal itself. Rejected too. And notice, we only ever use the public key, never a secret. So anyone can verify, yet an attacker without a secret key can't forge a new seal. Made in secret, checked in public. That's the power of signatures. A public key is a bit long, too long to type as a destination, so we fold it down into an address, basically an account number. Then let's generate some. Like this. From the same key, Bitcoin gives an address starting with 1, and Ethereum starts with 0x, and so on looks different again. Each chain folds it a little differently, but they all share this. An address is safe to share and you can't get the key back from it. But this may change with the advancement of quantum computers, however. And that pop from our very first diagram. This address is who Bob really was. Put it all together and you get a transaction. Alongside the payee and amount, it carries the blue public key and the red signature. That signature proves the right to move this money is yours. Then let's broadcast it. There's no boss here. Instead, every node verifies the signature independently, and they all accept it, so it goes into a block. Then now let's try a hijack. Like this. Change the payee, bump the amount, and broadcast again. And every node rejects it at once. Permission doesn't come from who you are. It comes from a valid signature. That's the engine that lets this run with no central authority. Finally, how to guard the key. The flip side of all this power. Lose a key and the funds are gone forever. Liquid and they are stolen instantly. No boss means no one to bail you out. Not your keys, not your coins. And one technical trap. Remember that fresh random number. If you reuse it, watch what happens. I'll switch to promote and run the demo. This one. Sign two different transactions with the same random number and look. From just those two signatures, an attacker recovers your entire private key. This actually happened on the PlayStation 3 and early wallets. That's why modern wallets derive that number deterministically. One slip and you lose everything. A great lesson. 5 lines to recap. 1. 2 keys. Sign with the private, check with the public. 2. Made in secret, checked in public. 3. A signature is baked into the content, so changing one character breaks it, and it's not encryption. 4. An address is a public key's fingerprint, and permission comes from a valid signature, not an identity. 5. The key is everything. Everything you touched today was real cryptography, computed in your browser. The link is in the description. Go play with it yourself. You can switch between easy and promote. If this helped, subscribe and drop a like. See you in the next one. Bye.